Hey everybody, this is Mrs. Harding. Today I'm going to help you through activity C in your packet. We're going to solve equations graphically today. So flip to your note page. Take a look at the problems on the top. It says solve the following inequalities algebraically. So this is what we would have done in the past. Here it says absolute value of 5x plus 6 is less than 4. You would have said 5x plus 6 is less than 4 and it's greater than negative 4. Gone through the steps to solve it. Divide by 5 here at the end. And then you would have said that x is greater than negative 2, less than negative 2/5, or negative 2 to negative 2/5, like that. What if the sign had been the other way? If it said absolute value 5x plus 6 is greater than or equal to 4, the way that you would have solved this would be to say 5x plus 6 is greater than or equal to 4, or 5x plus 6 is less than or equal to negative 4. Remember, you can't write that all as one statement. Something can't be greater than 4 and less than negative 4. And so when you go through to solve this, you're going to get the same two numbers. We're just going to be looking at the opposite direction. So x is greater than or equal to negative 2/5, or x is less than or equal to negative 2. So we would have said from negative infinity to negative 2 inclusive, and then negative 2/5 to infinity. Notice that we had the same two numbers, just sometime the solution to number 1 was in between the two numbers. The solution to number 2 was less than negative 2, greater than negative 2/5. So how do we come up with solutions to inequalities? By looking at the graphs instead. Take a look at the graphs here in number 3. You have y1 in blue, y2 in red. And question 3a says what x values make them equal to each other. Easy enough, we've done that for a couple of days here. It's when x is equal to 0, and when x is equal to 1, 2, 3, 4, 5, 6, negative 6. So now let's think about this instead. When is y1 less than y2? When is the output of this function, the blue function, less than the output of y2? It's any place in here. The y value of the blue graph is less than the y value of the red graph. So we would say that this is from negative 6 to 0. All right, let's try this next one. It says what x values make y1 equal to y2? Well, the x values 2 and 6. So x is equal to 2, x is equal to 6. Where is y1 greater than or equal to y2? Where is the output of the blue graph larger than the output of the red graph? Well, that would be from this point to infinity and this point to infinity. So there's actually two intervals. It would be from negative infinity until 2, then again from 6 to infinity. So you can see from the outputs of the graph how you can solve an inequality. So let's take a look here. Question number 5, use the graphs below to complete the inequality, then identify the solutions. Okay, we're looking for when is x plus 3 less than or equal to, we'll look at the red line. This is just the line at 2. So when is x plus 3 less than or equal to 2? So where's the output of the blue graph less than 2? The output of the blue graph is less than 2 here from when x is negative 5 until x is at negative 1. So from negative 5 to negative 1, the absolute value of x plus 3 is less than 2. All right, take a look here. We need to fill in this blank. The absolute value of x plus something is less than 3. Well, think back to your transformations. This is an absolute value graph. It's been shifted up 1, 2, 3, 4 places. So we're wondering when the absolute value of x plus 4 is less than 3. So take a close look at this graph. When is this blue V shape less than 3? Well, it never is. So the answer to this one is no solution. Okay, turn to the next page. We're going to start doing this in our calculators. Take a look at number 6. It says the absolute value of 5x plus 1 is less than or equal to 7. All right, so what does that mean? In our calculators, we're going to go here. We're going to get the absolute value of 5x plus 1. Oops, I hit 11 by mistake. There we go. And then 7. Now, if your calculator like mine is on a different window from the work that we've been doing, you can always hit Zoom 6, which is Zoom standard. We'll take a look at the picture there. So when is absolute value of 5x plus 1 less than or equal to 7? Well, you can see it's going to be here from whatever this intersection point is until this intersection point. The absolute value is below 7. So let's figure out what those points are. We're going to go second, trace, number 5, first curve, enter, second curve, enter, guess. I'm going to find this one on the left side first. There we go. Looks like it's at negative 1.6. So I know in my picture that I'm looking at here where x is negative 1.6. Now I need the other one. I'm going to go back to the calculator. Second trace, number 5, enter, enter. And then for the guess, I want to get the other intersection point. It'll just take a second. And then, oops, hit it a bunch of times. 1.2 is the other intersection point. So then this intersection point happens at 1.2. So when is the absolute value less than 7? It's in this whole area from negative 1.6 to positive 1.2. Oops, again, I need a bracket. Any number in this interval is going to result in a value on the left side that is less than or equal to 7. Go ahead and pause the video for a second. I would like you to try the next 3 yourself. Okay, take a look, check the answers that you got for this. All right, so then we can also apply this to the word problems that we've worked on in the past. Take a look at number 10. The height of a jetliner during a flight is given by y equals negative 5,000 x squared plus 20,000 x, where x equals the number of hours since takeoff and y equals height in feet. The first part says graph this on your calculator. Okay, let's go back to our calculator. Clear out what we put in there before. And I'm going to graph negative 5,000 x squared plus 20,000, all my zeros in there, x. Now, as you can anticipate, this is probably going to go up pretty high. So it's not really going to fit on our graph here. You can see it, but the top of it is very, very high up. So let's go up here and let's throw in, let me go to my Y max. Let's go up to maybe 25,000. And I would recommend changing your Y scale to 0. The Y scale is just how close together the calculator puts tick marks. And when you have such a big number, it's not going to be able to put tick marks in all 25,000 spots. Okay, let's see how this went for us. Oh, not bad. I'm going to change it a little bit more to get rid of some of the area to the left and maybe even some of the area to the right. Let's see how this looks. There we go, not bad. All right, so when is the plane above 15,000 feet? Okay, so let's go back to here. I'm going to put a line in at 15,000 and then graph it. All right, you can see what that looks like. Let's pause for just a second and get this picture in. So we know we have an upside down parabola going through the origin. There we go. We have a line at 15,000. And so then the question here, when is the plane above 15,000? Well, above 15,000 would be from this point to this point. Here's the point where the plane is that high in the air. So let's go back to the calculator and find those intersection points. Second trace, 5, enter, enter. See which one it finds for us first. The one there on the right is at 3. That's a good number. So this is at 3, comma, 15,000. Let's take a look at the other one. Second trace, number 5, enter, enter. Now for the guess, we want the other intersection point. Just take a second to get over there. I think it's close enough. And that one happens at x equals 1. So then this intersection point is the point 1, 15,000. So when is the plane above 15,000 feet? From 1 to 3 hours. All right, part C. When is the plane on the ground? Well, clearly that should make sense at 0 hours. And then when is the plane here? Well, this is when does the plane have a height of 0? So we're going to go in here. I'm going to add in a 0. Oops, double 0. It's all the same. You can sort of see a little line over the top there. So now pay attention to this when we do an intersection. Second trace, number 5, because now I don't have 2 equations in there. I have 3. So first curve, yes, that's definitely one I want to find the intersection of. But 15,000 isn't the other one that I want to find the intersection of. So you can use your up and down arrows to toggle between the equations. So this is the other equation that I want to find the intersection with. So I hit enter again, and then it changed to guess. Enter for the guess at 4 hours. So this right here is the 0.40. So it's at 0 hours and at 4 hours after takeoff. When is the plane below 8,000 feet? When is the plane between 8,000 and 10,000? Why don't you pause the video and I want you to try D and E yourself. Okay, take a look. I drew in the line at 8,000 in green. Forgot my parentheses there. So you can see the intersection points were after 0.45 hours and after 3.55 hours. So when is the plane below 8,000? 0 to 0.45, and then again 3.55 to 4. When is the plane between 8,000 and 10,000 inclusive? And then you can see the answers there. So hopefully that helps. This last problem we're going to skip for now. We might use that as a warm-up when I see you on Wednesday. What you should use the rest of the class period today for is to complete homework that goes along with Activity C. I will see you all on Wednesday.